innovation in anatomic plate design. It combines the benefits of low-profile titanium plate metallurgy with the advantages of multi-planar lock screw technology. These features allow the formation of a three-dimensional matrix of fixed and variable angle screws to create a true subchondral scaffold that can provide solid fixation in comminuted fractures and osteoporotic bone. The A.L.P.S hand fracture plating system features Timax, low-profile anatomically contoured implants. In hand surgery where soft tissue coverage is at risk, these low-profile plates are designed to minimize discomfort and soft tissue irritation, matching the anatomy of the phalanx and metacarpal. The system features fast guide and flexible plating technology to facilitate surgical procedures and save time in the operating room. Fast guides come preloaded and do not require intraoperative assembly, resulting in reduced OR time per procedure. Additionally, the A.L.P.S hand fracture plating system allows the use of locking, variable angle, and standard screws. This hybrid fixation concept allows the surgeon to stabilize the fracture either by the use of lag screw techniques through the plate or by compression plating techniques. Locking screws serve to provide stability to comminuted unstable metaphyseal fractures or in osteopenic bone. To apply an A.L.P.S hand fracture plate to a metacarpal or phalanx fracture, begin by assessing the fracture fluoroscopically. Make an incision to expose the fracture site. Common approaches include a dorsal incision for metacarpals and either a dorsal or lateral incision for phalanges. After adequate exposure and irrigation of the incision site, reduce the fracture. This can usually be done visually, but in instances of comminuted fractures, the use of fluoroscopy may be helpful. Achieve provisional stabilization of the fracture using towel or reduction clamps or K-wires. Determine the appropriate plate shape and length. Plates can be trimmed and shortened to more closely match the anatomy and fracture geometry. After determining the necessary plate shape and length, prepare the plate using the plate cutters and/or the plate benders. Plate benders can be inserted over or through the fast guide inserts for contouring prior to fixation, and can also be used in situ after provisional fixation, proximally or distally to the fracture. Next, achieve temporary fixation of the plate to the bone using K-wires or reduction clamps. Drill through the fast guide using the appropriate drill bit. Use the bone depth gauge to measure the hole and determine the appropriate length screw. For your convenience, the bone depth gauge has two measurement systems on the same side, depending on whether the tool was used through a fast guide or after the fast guide has been removed. Remove the fast guide using the driver and select a locking, non-locking, or multi-directional locking screw based on the plate hole and type of fracture. When desired, a 1.5 mm non-locking screw or 2.5 mm locking screw paired with a washer can be placed through a compression hole to achieve compression at the fracture site. Use the same driver to insert the screw into the plate. Throughout the application, the plates can be bent, twisted, and curved in situ, utilizing the plate benders. For axial and coronal bends, place the long end of the benders over or into the fast guide inserts of adjacent nodes. For sagittal bends, place the short end of the benders over the fast guide inserts of adjacent nodes. Hold one bender as an anchor while manipulating the other bender to create an in situ bend. When using a multi-directional screw, remove the fast guide prior to drilling. Drill through the soft tissue guide with appropriate drill in the desired direction. It is recommended that the hole is not drilled more than 10 degrees off axis. Once the screws have been inserted, confirm final plate and fracture fixation using fluoroscopy and close the incision site. Postoperative management will vary by surgeon preference. The A.L.P.S hand fracture system surgical technique was developed in collaboration with Dr. Matthew Tomeno and Dr. Lloyd Champagne.